The simple pendulum. A simple pendulum consists of a mass at the end of a lightweight cord. We assume that the cord does not stretch and that the mass is negligible. In order to be in simple harmonic motion, the restoring force must be proportional to the negative of the displacement. Here we have F equals negative mg sine theta, which is proportional to sine theta and not theta itself. But we really don't need to worry about this because for small angles, meaning less than 15 degrees or so, sine theta is about the same as theta, and x is equal to L times theta. So we can replace sine theta with x over L. So we have F is approximately equal to negative mg over L times x. F is equal to negative mg over L times x has the same form as F equals negative k times x, if k is equal to mg over L. So we learned before that t is equal to 2 pi square root of m over k. So let's replace k with mg over L. You can see that the m's cancel out and we get t equals 2 pi square root of L over g. Or if you're looking for frequency, you get F equals 1 over 2 pi times the square root of g over L. Again, notice that m canceled out, which means the mass does not matter. So as long as the cord can be considered massless and the amplitude is small, the period does not depend on the mass.